Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 2, Part 1. And in Chapter 2, we are going to be studying matter and atoms. So, some essential questions that you should be able to answer at the end of Chapter 2. What is matter made of? What is the explanation for the diversity of matter? And how do we explain properties like the states of matter, solid, liquid, or gas? Let's take a look at the introductory pages, pages 36 and 37. So looking in your book, on page 36, we know we have our introductory pages for Chapter 2, Matter and Atoms, our essential questions, and then make sure you've read these pages. During our class discussion, you should be able to answer like, what is matter made out of? Coal, cellophane, wood. What are the similarities and differences between like cellophane and wood? You should have looked through this chemical reaction and be able to tell me about mixtures and polyvinyl acetate. So make sure you've read that and that you're ready to discuss it, and let's jump into our notes today. So 2.1, matter and elements. So let's talk about pure substances. Pure substances can either be compounds or elements, and a pure substance is matter that has the same composition and properties throughout. Doesn't matter if you take a sample from here or from here or from here of the substance, it will have the same composition and it'll have the same exact properties. Also, pure substances cannot be separated by physical means, which means you can't boil them to separate them, you can't cut them up to separate them, you can't pick them apart, those physical means. So I want you to see if you can come up with some examples. There are literally thousands of examples. All of the elements and compounds are pure substances. Anything that, if it's a mixture, it doesn't make the cut, but hydrogen, gold are elements, and carbon dioxide and water are compounds, so please write those down. Like I said, mixtures are not pure substances, those are a different thing, and that is a combination of two or more substances where each type of matter retains its own properties and its own composition. Let's take a look at page 38 to kind of, hopefully that'll make a little more sense. Looking on page 38, we see a couple examples of mixtures. Oil and vinegar is an example of a mixture. The oil is a pure substance and the vinegar is a pure substance. And then when you mix them together, you get a mixture. The oil and the vinegar both retain their own properties and their own composition. So they haven't combined chemically to make a new thing. You could separate it by physical means. Not super easy, but you could definitely separate these two without a chemical reaction. And looking at our picture, we see we have a mixture, and you can see that it retains its properties, and you could separate it out into these 5 different substances. So looking at mixtures, they can be separated by physical means. So that's how they're different than pure substances. And so I want you to come up with some examples of mixtures. So some examples of mixtures are salt water. The salt and the water can be separated. Trail mix. I can pick out all the M&Ms in trail mix. And salt and pepper. It'll be a little bit harder, but you can separate those by physical means. And all of the substances in these mixtures keep their own composition and keep their own properties. Like when you have M&Ms in trail mix, they keep their M&M-ness. So there are literally thousands of mixtures. I do want you to write those 3 down, please. So let's talk about physical properties and physical changes. So physical properties are properties that can be directly observed and measured. Looking at page 39, let's look at some physical changes and physical properties. So as you remember, physical properties are properties that you can directly observe and measure, and a physical change is something you can also observe and measure, and it doesn't change the composition of the substance. So temperature is a physical property. You can directly measure that, and then if the temperature changes, you still have water. It hasn't changed the composition. Brittleness and malleability are physical properties. You can bend gold. Hard to bend glass, it will tend to shatter. And even shattered glass, even though the object has changed, the glass hasn't changed its composition. It's just tinier. Density is another physical property, and you can observe that and you can measure it. And then this one, phase changes, often gives people a little bit of heartache. These are not chemical changes. Phase changes are physical changes, because even when you heat something up, let's say you boil water, it's no longer water, but it is still H2O. So water vapor is H2O. You haven't changed the composition, you've just changed the state of matter. So physical changes are reversible. You can take that water vapor and condense it back into liquid water. Coming back to our notes, let's write down some physical properties. Density is one. State of matter, solid, liquid, and gas, is another physical property. Boiling point, the temperature at which a liquid boils, is another one. Melting point is another physical property. And ductile, which is the ability to be drawn into wires. Copper is a really ductile element. A lot of elements aren't ductile. For example, chlorine is not ductile. There's no way you're going to put that into a wire. Malleable is another physical property, and that is the ability to be hammered into shape. So silver, gold, those are really good at being malleable. You can pound it into a ring or into a flat piece of metal. Table salt, if you try hammering that into a sheet, it's not going to work. So those are all physical properties. Let's talk about physical changes. Physical changes are any change that does not change the chemical composition of a substance. So anything you do to salt and it still stays NaCl would be a physical change. Anything you do to water and it still stays H2O would be a physical change. There are lots of examples. Boiling water is one. We talked about that, how even though it's no longer liquid water, it is still H2O. Freezing carbon dioxide. So carbon dioxide you can freeze into a solid, that is dry ice, and it is still CO2. Dissolving salt in water, you can still get that salt back. The salt is still NaCl. Let's talk about intensive versus extensive properties. So extensive properties are physical properties that depend on the size of the sample. Let's take a look at page 40. So we can see that mass is an extensive physical property. It depends on how much you have. Whereas density is not an extensive, it's the opposite, it's an intensive property, and it does not depend on the amount that you have. If you have a little block of copper, or if you have a whole building of copper, it will have the same density no matter how much you have. Coming back to our notes, two examples of extensive properties are mass and volume. Please write those down. And they do depend. You'll have a bigger mass if you have a bigger size of the sample. You'll have a bigger volume if you have a bigger size of the sample. So they definitely depend on how much you have. So the opposite, physical properties that do not depend on the size of the sample. So these would be our characteristic properties. See if you can recall a characteristic property that we studied freshman year. Okay, the three characteristic properties or intensive physical properties we studied freshman year were density, boiling point, and melting point. Did you get any of those? If so, good job. Please do write all three of those down. Moving on from physical changes, we're going to go to chemical properties and chemical changes. So a chemical property is different than a physical property. Chemical property can only be seen as a chemical change is happening. So some examples are combustible, which is another word for flammable, and oxidizing. An example of oxidizing is iron rusting. So if I were to check to see if this piece of paper is combustible, I would have to light it on fire, and then I would no longer have paper. So there would be a chemical change, and I would no longer have paper. Again, oxidizing, you can only see that it is, the iron is easily oxidized after the iron has rusted, and then it is no longer iron, it's actually iron oxide. So it has chemically changed. So chemical changes are chemical reaction, that's another word for it, and you will see me use this abbreviation RXN, and that is an abbreviation for reaction. If you look back at your notes and be like, just write out reaction so you know what you're talking about. So chemical changes are any change in which the substance has been converted into a new substance and has different properties. So please write down that example of a chemical change. So when you combine baking soda and vinegar, there is a chemical change that occurs, and the baking soda and vinegar have been converted into new substances that have different properties. You get carbon dioxide, water, and sodium acetate. So you don't need to write down the chemical formulas, but let's talk about it. So you have baking soda, which is sodium bicarbonate, and then you have vinegar, which is acetic acid, and then those chemically react and you get new substances that have new properties. Carbon dioxide, definitely different properties than baking soda. Water, again, definitely different properties than baking soda. And sodium acetate, which is a salt dissolved in the water. You wouldn't see it, but it is there. You don't need to write this down, but we will be getting into this later. On the left side of a chemical equation are the reactants, and the right side are the products. So how do we know if a chemical reaction occurred? Well, let's look at the indicators of a chemical reaction. So these following things suggest a chemical reaction or a chemical change has occurred. Every once in a while, there are some physical changes that will also give these indicators. So let's talk about one that might be confusing. So first up is a change in temperature. Often during a chemical reaction, there is a change in temperature. A lot of times it gets hot, sometimes it gets cooler. So an example is the combustion of hairspray. So if you light hairspray on fire, it will be on fire and it'll be hot. There will be a change in temperature. So we don't want to get this confused with a physical change. You can physically change the temperature without changing the state of matter, but without changing the chemical composition. So when water vapor condenses back into liquid water, that is a physical change. It was H2O, it's still H2O, and some heat was given off. There was a change in temperature, but it didn't change its composition. Whereas when hairspray combusts, chemically it's different. You're not getting that hairspray back. We're going to go through one more, and then we're going to talk about the rest of them in the next video. So another indication of a chemical reaction is the production of a gas. So when you put baking soda in vinegar, you get carbon dioxide, you get those bubbles, and that is a chemical reaction. Sometimes you don't want to confuse it with a physical change. So when you have pop, which is carbon dioxide is dissolved in your pop, and then when the fizz comes out, that's the carbon dioxide leaving, but there's not a chemical reaction. The carbon dioxide is just going from inside the pop to the atmosphere. Okay, so let's pause there and talk about the last two in our next video. I will see you then.